Almost any voice agent twice, and the second time it greets you like a total stranger. No idea who you are, no memory of the last conversation, no clue about your account or anything else. So today we're going to fix that with two tools. LiveKit for the voice and Supabase for everything that the agent needs to remember. And the best part is the memory, the search, the auth, that all lives in one Postgres database. No separate vector store or extra embedding provider.
Hey there, I'm your Supabase-backed voice assistant. What's your name?
Jesse.
Nice to meet you, Jesse. What can I help you with today?
Yeah, can you remember that my favorite color is teal?
Got it. I'll remember that your favorite color is teal.
So you saw there in the database that the memory landed right there in Postgres. It was scoped to the user the moment that I set it. And so let me ask it something that it doesn't know from its own context next. How do voice agents handle interruptions?
Voice agents handle interruptions, often called barge in, by constantly listening even while they're speaking.
So that answer came from a knowledge base using vector search inside of Postgres. And so next, let's do another test. I'm going to hang up, reload the page, and then come back as the same person. So let's restart and start the call again.
Hey, Jesse, good to hear from you. What's up?
Hey, yeah. So what's my favorite color?
Your favorite color is teal.
Oh, amazing. Can you actually update my favorite color? My favorite color is actually black.
Got it. I've updated your favorite color to black.
Amazing. Thank you. So it remembered me across a fresh session with no login screen. And here's the Supabase part that I really like, that identity, it's real. And so let me prove that in isolation. I have an incognito window opened up here now on the side. So let's start this.
Hey there, I'm your Supabase-backed voice assistant. What's your name?
My name is Francis.
Nice to meet you, Francis. How can I help today?
Amazing. Can you remember that my favorite color is purple?
Got it. I'll remember that your favorite color is purple.
Awesome.
What else?
Great. So let's check this out. We've got a new ID here and let's refresh it. This one is Francis. And if we go over to memories, refresh that, we should have another favorite color for this specific user. That's purple. So a different person, different data enforced by the database itself. And okay, so this is the goal, but now let me show you how little code this takes. The shape is straightforward. The browser talks to LiveKit Cloud over WebRTC, and LiveKit handles speech to text, the language model, and text to speech. Your agent gets called through tools. Everything that the agent remembers or looks up lives in Supabase. Postgres for the data, pgvector for similarity search, Supabase auth for identity, and row-level security so users can't see each other's rows. And embeddings come from a Supabase edge function running a small model called gte-small right next to your data. And so there is no third-party embedding provider to sign up for. One database does identity, storage, search, and embeddings. So this starter ships a TypeScript agent and a matching Python agent. And I'm going to walk you through the TypeScript one, but everything maps one-to-one if you prefer Python. Here's how the agent knows who you are before you say a word. And it's the biggest difference from a typical starter. There's no homemade cookie here. On load, the browser signs in anonymously with Supabase auth. That mints a real user with a real ID and a token. And so no email is required here because this is anonymous authentication. When the page asks for a LiveKit token, the server verifies the session and reads the user ID for the verified user, never from the request body. And so then it hands that ID to the agent through dispatch metadata. So the client can't fake who it is. And the isolation that you saw in the demo, that is this policy right here. auth.uid equals user ID. So the database refuses to hand one user another user's rows. And so the database is doing the work here, not your app code. And this, again, this is called row level security. Okay, so that is identity. Everything else that the agent does comes down to 5 patterns plus a bonus, so stick around to the end. I'll keep each one short, the smallest snippet that makes the point, and then move on. Pattern 1 is retrieval. The knowledge base is just a Postgres table with a vector column and an index for fast cosine search. Retrieval is a tiny SQL function. Embed the question, order the distance, and return the top few rows. Pattern 2 is memory. Each fact lives in a slot or a row per user per label. So saying your favorite color twice updates it instead of piling up duplicates. Writing it is a single upsert, and a generated TS vector column keeps full text search in sync. Retrieval is where it gets interesting. Pure vector search is great at meaning, but it can miss short literal values. Pure text search nails the exact word, but it misses paraphrases. So we can run both and then fuse the rankings with Reciprocal Rank Fusion, weighted toward meaning while keeping the literal hints. And so it all happens in one SQL function scoped to the user. The agent gets 5 memory tools: remember, recall, forget, search, and list. Search runs the hybrid retrieval by meaning, and if embeddings do fail, it will fail quietly and fall back to text only. Memory should be the last thing to break. Pattern 3 is preloading. Before the agent connects to the room, it loads your profile and your past memories and then drops them into the context. So the model already knows who you are from the very beginning. And it resolves your ID from dispatch metadata before connecting. So that lookup runs in parallel with the room connection instead of adding latency. Pattern 4 is CRUD: create, read, update, and delete. So basically calling your backend. Here the agent looks up an order ID. Swap this order table out for inventory or bookings or account or whatever, and then you've got the shape for anything that the agent needs to fetch on demand. If the row is missing, we hand the model a clean error, and it can apologize then and move on instead of crashing. Pattern 5 runs when the call ends. The agent writes a structured report of the session to a session table. So notice that the table has no insert policy for regular users, so only the backend holding the secret key can write history. A few hundred calls then becomes a dataset that you can analyze without leaving Supabase. And now for that bonus that I promised, it's the thing that keeps everything honest. Every embedding in the whole project for the seed data and for live queries comes from this one edge function. You define the model once, and then the seed script and both agents will stay in sync automatically. And running this is just a handful of commands. Install everything, link the Supabase CLI to your project, push the schema, deploy the embed function, and seed some demo data. Then start the agent and the front end together with one command. And there's just 2 clicks to do in the Supabase dashboard. You'll want to turn in anonymous signups. That's under authentication, sign in, and providers. And then anonymous signups here, just turn that on. And then grab your API keys. So again, under your settings, API keys, and you've got this publishable key and your secrets key. After that, you're ready to go. And if you'd rather not run the web app while you're building, LiveKit has a hosted agent console that talks straight to your local agent. So just run the dev mode, launch the console, and start talking. So that's a voice agent with real memory, real identity, and real search, all powered by LiveKit and Supabase. Clone the starter, point it at a Supabase project and a LiveKit cloud project, run pm dev, and you'll be talking to it in just a few minutes. The repo and the full written guide are linked in the description as well. And if this video was helpful, give it a like and subscribe for more voice AI content like this.